Hi guys, we're starting the second lesson of the second unit, which is linear versus exponential functions. Our essential question for today is, how do I tell if the function is linear or exponential from the different representations? So what's happening today is similar to yesterday, only we're not describing the functions. We're just giving you a function and want you to tell us if it's linear or exponential and why it's linear or exponential. So on that point, we're going to talk about a few things that make it linear or exponential. So if I'm given an equation, what makes it linear? Well, a linear equation is in the form y equals mx plus b, right? So if it's in that form, it's linear. It could be b plus mx. The m could be at the end and the b could be at the first. That's fine. But I'm adding a number to another number with an x. Okay? Exponential. What does an exponential equation look like? Y equals a times b to the x power. So I'm taking two numbers, multiplying them together. Well, that's what it says, a times b to the x. But order of operations says I have to take b to that x power first, right? My x, my variable, is an exponent. And that's what makes it exponential, is because that variable is an exponent. Great. So the next thing we're going to look at is a table. So what makes the difference on a table if it's linear or exponential? Well, if it's a linear, I have a common difference. Right? We're going to kind of treat a table like a sequence. We're going to find out what the common difference or common ratio is, and that's what we're going to do. And if it's exponential, I have a common ratio. Yeah. Okay? So I want to find out what that is. And then the last thing we're going to look at is a graph. We actually have one other thing to look at, but we haven't talked about that yet, so we're going to talk about it today. Let's talk about linear. What makes a graph linear? Well, it's a what? It's a straight line. Yep, straight line. And if it's exponential, what makes a graph exponential? Well, what makes a graph exponential is if it's curved up on one side, right? On one side. Okay? And it doesn't matter which side, one side or the other can be curved up. It doesn't matter, just as long as one side is curved up. So those are kind of our definitions, if you want to say, or what we defined as being linear exponential for each of those three, if it's equation, table, or graph. And our fourth thing we're going to look at is a story problem. And when we get there, I'll tell you what we're going to do and how we're going to decide if it's linear or exponential, okay? So here we go. Let's look at A. Is A linear or is it exponential? And why? So it says, is it linear, exponential, and why? So if I look at this, if I look at my x, where's my x at? My x is the exponent. Very good. So that means if my x is the exponent, that means that it is exponential. Did I say why it's exponential? Yeah, because I said my variable, or x, is the exponent, and that makes it exponential. Good. So I've said why. I don't have enough room to write it out, but we should probably write it out, okay? The next one on B, I have another equation. And look, I'm pretty sure this is of the form mx plus b. M is 6 and b is 4. So that makes it linear. Why is it? Because it's of the form y equals mx plus b. It's linear. Okay, so now let's look at my graph, number C. What does the graph look like? Well, it's curved here, and it's curved up on one side. One side is not curved, one side is. So this side isn't curved, this side is, and it's curving up here. So this is exponential. Great. Curved up on one side. Good job. Okay, and now we're going to look at this table. So the first thing I want to look at when I'm looking at the table is my x's to see if there's a difference of only one, and it is. Now, I'm going to do the same thing if there's a difference of other than one. But if I just want to make sure my difference is the same for each one, and -1, 0, 1, 2, 3, they're all in order, so I'm good. Now I want to find out what my difference here and here and here, or my ratio, right? I could be multiplying. What would I multiply -1 by to get 3? Well, -3. And is 3 times -3 7? No, that's -9. So it's not multiplication. So how else can I get from -1 to 3? Well, -1, 0, 1, 2, 3. That's 4, adding 4. And 3 plus 4 is 7. And 7 plus 4 is 11. And 11 plus 4 is 15. So it looks like we're adding 4 every time. So I have a common difference of 4. So that means this is linear. And notice I'm really giving the reason why it's linear before I'm actually saying that it's linear. I'm finding the reason why it's linear before. Is that okay? Sure it is. It's okay to do it that way. Okay, E. We have a story problem now. It says your savings account starts with $300. So I have $300 in my savings account. Every Friday, I deposit $50 into my account. So let's just make a table. I think that's the easiest, right? So if I started, I deposited $300, okay? So my first deposit, I add 50, right? I put $50 in there, so that means I have $350. On my second deposit, how much do I put in there? Another $50. So that means I have $400. So what's happening every time is I'm going up by 50. So I have a common difference of 50, which means this is linear. So what did I do? I took my story problem and turned it into a table. It's the easiest way. Take your story problem, turn it into a table, and then I can just use one of my 3 that I have. I can use my equation, information, my table, or my graph. The easiest way is to turn it into a table, and then I can use my information to decide if it's linear, or my table to decide if it's linear or exponential from there. I hope that kind of helps a little bit with the story problem. I just always put it into a table. It's easiest. You may decide to try and graph it first. However you can see the story problem is wonderful. Okay, so D. So again, on D, what I'm going to look at is my X values. And once again, we've got a difference of 1 in the X, so I'm good there. So I want to see what my difference is from here to here, and here to here, and here to here, and here to here. So what do I add 3/4 to get 3? That's like 2 1/4 or something. And since none of the rest of them have fractions, I'm pretty sure I'm not adding. So let's look at 3 to 12. How do I get from 3 to 12? Well, 3 times 4 is 12. What's 12 times 4? 48. Good. Yeah. I can use my get out your calculator if you're not sure I'm doing it right? 4 times 48, a little harder, but 4 times 48 actually is 12. Now, if we want to make sure that 3/4 times 4 equals 3, well, we can do that. That's 12/4, and 12/4 equals 3. So yeah, I'm still multiplying by 4 there. Okay, so that means I have a common ratio of 4, and that means that it is exponential. Okay, great. And then E is a line. It's a graph. Sorry, it's a line. It's a graph, and it's straight. There's no curves. It's totally straight. So this is linear because it's a what? Straight. S-T-R-I-A-G-H-T. Straight line. Can't spell the word straight. It's a straight line. There you go, guys. And the last one, F, is another story problem. It says your savings account starts with $10. So I've got my savings account. I put $10 in it. So I started with 10. I'm going to just use 0. Every month, so the first month, my account doubles. So what does double mean? So it goes from 10 to 20. Okay, so I could add 10. On the second month, what does double mean? It goes from 20 to 40. Yeah, good. So what is happening every time? Double means I'm multiplying by 2. Good. So I have a common ratio of 2, which means that it is exponential. Great. Okay, so I'm multiplying, so it's exponential. Good job. So now you're going to do a little bit of homework, and we'll see you back for the third lesson. Have a great night. Bye, guys.